Hi, it's Chris the Guitar Amp Tech here from Sydney, Australia. Today we've got a Marshall 4203. This is the model with the solid state preamp and the tube power stage, and lights are on but nobody's home. Got to get this going again for the customer. If that sounds like of interest to you, go and grab a coffee, pull up a chair and help me out. See you soon.
Mate, social distancing, please. Social distancing, if you don't mind. Can you please take a step further back? That's better. Whew. Okay, now I can take my mask off. Man, I'll be glad when this corona thing's finished. Okay, I've found it. The Artist 4203. It gets one paragraph in the Marshall book, and basically it tells us what we can see from the schematic, and that is it's a solid state preamp with a valve power stage. It's also got a send and return effects loop. So if it were me, what I would do is I'd plug something like that into the return jack. A nice valve preamp, and this thing's going to be really rocking. It'll probably sound fine with the solid state preamp, but hey, it goes against Marshall tradition, doesn't it? Well, early Marshall tradition. Okay, if you just look over my shoulder, I've got it running through my current limiter, my bulb current limiter there, right there. And when I turn this power on, if it's fine, we'll see it go glow bright as we charge the caps, and then it'll slowly dim. And when I do the standby on, probably the same thing, it'll go bright again and then come down. Let's have a look. Okay, that's looking good. I don't know if you can see that, but it went bright, then dim. Let's try the standby now. Okay, that's looking pretty much what we'd expect, for it to glow bright and then come back down again as those caps charge. Oh, that was promising. We got some sound at least. Let me just put some music through. Okay. We got nothing there. Let me try this in the return jack now. Okay, that's basically told us one thing, because that send return happens just before it's between the preamp and the power stage. The fact that we've got the power stage working by putting the return in means that we've now isolated the problem to the preamp. So let's pull the chassis out and see if we can find what the story is here. All right. I am sensing an amplifier from February 1987. Oh, wait. January 1987. That's pretty old. Oh, look at that. I was right. Who'd have thought? Ding. Good old Sharon signed it off 6th of January 1987. But on the more serious consideration is that LCR capacitor there, which you're probably not going to see, is dated end of 1986. It's 2020 now. That makes it 34 years old. Ouch. That's going to have to get changed. On my amps, I change them every 10 years. For a customer, I'd say every 15 if they're a gigging customer, as this one is.
34 years, that's just taken a bit of a risk. I think we'll change that. While we're at it, probably change that one as well. And I'll have a think about these. But definitely that one and the main multi-cap. I've just been poking around here and I think this is going to be largely a bit of a cleanup. We're definitely going to change that multi-cap can and the other filter cap here. But I think the rest of it's going to be a bit of a cleanup. I can hear a buzz, it's probably a bad earth somewhere, but have a listen to this. And that's just from me jiggling the things around. So that's the send signal going off to my other little workshop amp. So we might be in luck. Let's start. We'll change the filter caps. We'll pull out that board, give it a bit of a clean. I want to clean that send return jack because that's a common fault because the signal goes through the send depending on its contact closure in the actual jack back into the return. And that's quite often where faults are in these. So let's give it a go and we'll be back soon. Can you see where you are? Yeah, let me tilt this up so you can have a better look. Now we're going to replace this capacitor next. Now what some people do is they'll just cut the leg off there and there, put the new capacitor in and solder it onto there. Look, it works 80% of the time. But sometimes just applying that heat there is enough to compromise the solder joint underneath there. So really the best way, painful as it is in some cases, is to remove the circuit board and do the soldering properly. In this case, we've got a bit of an easier operation. All we're going to do is remove the nuts from these 5 sockets and we're done. And I've removed those nuts, as you can see, and with a little bit of jiggling, there it is. So I'll now get on to removing that solder and that capacitor. Now one thing that Sharon and Tara didn't do in the original installation is they had the capacitor manufacturer side up, so we couldn't really see what the capacitance and resistance was, capacitance and voltage rather. But we're going to have it right side up, so I'll just measure this. Forgot to put a wee bit of elastic at the bottom. And just solder him in. Plenty of height underneath here, so we don't need to trim the legs too short and risk stressing that solder joint. We want the job looking neat. Beautiful. Okay, before I put the little board back, I think I'll just give all of these jacks a bit of a clean, especially these two, the send and receive. The signal literally goes through here and then back in here. So if any of these connections are a bit fouled, man, there goes your signal quality. So you've seen me do this before, so I'll just bore you with one and then I'll just do the rest Well, you're getting another cup of coffee, you lucky bugger. It's a bit of spray cleaner. Let a bit of deoxit, and I'll let it do its job. Cool. I'll do the rest and I'll be back shortly. While I got the board out, I may as well just reflow these solder connections here. Because they're soldered straight onto the boards, it's possible that these things can develop a crack, a tiny fracture, and then that's another problem. When you consider how quick it is to do this, it's just not worth skipping this step. Done. These are just plastic nuts on plastic shafts, so it's just finger tight and just a wee bit more. That'll do. Okay. Next thing we'll do is we'll do the same thing to these sockets here, which is input and foot switch. I'm going to service all of these because they were crackling with intermittence, so hopefully all these can be saved. Some of these knobs are pretty loose. It's that split spline shaft there, and they've just been pinched too close together, so I'll try and spread it apart a bit. At this stage, it's just so easy to snap that shaft, so I'm going to be very delicate about it. Give them a bit of a tighten while I'm here. That's a bit better. All right, I'll do the others, and then what I'm going to do is I'm just going to blow the dust out of them. This is going to be really noisy, so just block your ears. Next, I'm just going to spray them with a tiny bit of solvent. Just got to be careful with this because it can also flush the lubricant of the pot out. So I'm going to then just give them all a little touch of deoxit to lubricate it. Lock your ears again. A few years ago, I did myself a bit of a hamstring injury and I got a blood clot in my calf muscle. And for a little while, I had to inject myself with Clexane, a blood thinning drug, I think, for getting rid of the clots anyway. So I think, these look like they'd be a handy thing to inject a little bit of deoxit into that gap there in the pot. So as long as I'm careful to not inject myself with deoxit, I'm thinking it's probably going to be a pretty good idea. There you go. Beautiful. God knows if these tube sockets have ever been cleaned. So I'll apply my special secret sauce. Put that in and out a couple of times.
the other tube. Cheap and cheery Chinese. Just got a couple of tube pins here I need to push together. That's them. Secret sauce. Flush out secret sauce. Just get a bit of deoxit. This time I'll use this one. And that should just protect our contact. Hello. Because these are brand new capacitors, just going to bring the voltage up slowly. Already got a very high, for 6 volts supply, I've got 115 on the plate of the power tubes. That's 40 volts, 70 volts. I just set it there for a little while. Oh. Whoa, look at that. That's a fine Greek coffee there. A whole mug of it. Now, why am I talking with a Scottish accent when I'm Greek? Or Greek ancestry, anyway. So how you been spending your lockdown? I've been enjoying it. Some quiet time, catching up on some repairs that I've been lagging on. There's 100 volts, 235, 237. All right, that looks pretty good to me. Let me just have a bit of a poke around. So here's our screen, 438. What's our bias voltage? Minus 43. All right, I wonder if we're going to get a sound out of this now. Oh. Uh-huh. Oh, that's looking pretty good. I'm going to test those power tubes out next, and if they're good, we'll just bias it up and repack it. But looks like we've got that problem sorted. All right, let's check out these 2 EL34s. They should be warm by now. So the
plate current on these, if you can see this little table here, we should be seeing somewhere between 21 and 50. That's 46 on tube 2, 46.2. Tube 1. $49.0. Transconductance, we're hoping to see something over 4. And this is 4,000, yeah, so multiply by 1,000. Multiply by 1,000, and we got 6,500. And check tube 2. $6,150. That's pretty damn close. What's that? That's about 5%, I think. Good enough. Don't know what brand they are, but they're strong, they're well matched, so we're going to use them. Let's take this opportunity to show you another way of biasing the power tubes. I showed you how I do it with the oscilloscope last time. So this time we're going to do it by measuring the actual current going into the plate. So if you look at this, let's pull these two tubes out. And if we now measure the resistance from pin 3 on the socket, it's going to be that half of the primary winding of the output transformer to the top of that first filter cap. So that's going to give us that DC resistance of that winding, and then we're going to do the same here, the DC resistance of this winding. So we're going to measure pin 3 to that cap, pin 3 to that cap, and then we're going to put the tubes back in, power them back up, and we're going to measure the voltage drop across here from there to pin 3, from there to pin 3, put in a bit of Ohm's law, and we'll figure out the current that's going through those. And hopefully they're pretty well matched. The tubes were pretty well matched. And that'll give us our plate current. And if we need to bias it, adjust that bias, we can do that. Although in this amp, if I remember correctly, there is actually no bias adjustment. No. I mean, we can frig around and force a bias, but let's have a look and see what it is. We may not need to touch it. Okay, I'm measuring the resistance between the plate point, the tubes are out, between the plate connection and the filter cap, and on that first one we've got 46.0. I'm going to call that one, and same point on the other tube. 45.6. Okay, now let me get those tubes back in there, the speaker plugged in, power plugged in. I'll be right back. I practice what I preach about safety. Now, because I'm working with quite high voltages here, I'm not taking any chances. I've got my power plugged into an isolation transformer. I'm wearing my insulating gloves. Hopefully, if I touch anything, I don't go flying like Superman. So let's jot that down. So on, I think that was, we called that one V2. We've got 1.278, I'm going to call it. Here we got 1.053. All right, let's get Mr. Ohm happening. 1.278 divided by 45.6, and that's 28 milliamps on that one. And let's do the other one. And let's go 1.053 divided by 46. That's 22.9. Okay. That's quite cold. But we've also got a little bit of an imbalance. I'm just going to switch those two tubes around and do the same exercise again. I've now switched those two tubes around, and I'm just going to measure these voltages again. Sometimes tubes are just happier in one position or the other. Okay, so when I switch the tubes around, you can see that the bias pretty much followed the plate current pretty much followed the tubes around, so it wasn't a positional thing, it's just the difference in the tubes. And the current they draw is going to be dependent on what the bias point is, and obviously the bias point on the MaxiMatcher is different to the bias point of the actual amp. So we've got this discrepancy, and it's about 20%. So normally I'd say that's a bit much. Plus they're running cold. I'd be wanting to see more like mid-30s in the milliamp range. So decisions. I don't think this is the customer's principal amp, so I'm loath to go adding to her bill by replacing the power tubes, seeing they still check out as strong. I think what I'll do is I'll probably just see if I can warm that bias up a little bit. So having the bias a little bit cooler in itself doesn't worry me. It gives us longer tube life, it's going to give us more clean headroom, so long as we stay away from that nasty crossover distortion. The set point for this bias was -39, we're at -41, so we're just a little bit cooler than the design spec. I reckon we'll be okay, but I think we're going to still, sorry, a bit of Corona stuck in my throat. We'll just have to check it with the oscilloscope just to put my mind at ease. -41, so we're just a whisker cold. So as usual, I'm putting through about 1 kilohertz at 100 millivolts, 0.1 of a volt. Let's swing over here and we'll just start ramping this up a bit. So we're just monitoring that output now. And see, I can just see a bit of a tiny bit of a kink in here. I don't know if you can see that, just a slight kink. So that's the trace of that crossover. So I might just increase this voltage or decrease that negative voltage. Oh, where are we? So we've got to make this less negative. So if that's -39 there, that's 0 there. So we want to go more towards the 0. So we want to reduce this resistance here. So I'm going to put an increasing amount of parallel resistance across there, which will bring us closer to that 0 point. So I'm going to do that by jiggying my little decade box. I found this nice old vintage one, isn't it gorgeous? All right, so let's just, so I've got it set to 1 megohm at the moment, and I'm just going to slowly start decreasing this until I see a reduction in that kink. That'll do me.
I think we're just about there. All right, I'm happy with that. So I've got that now wound down to, what have I got? 400K. So if I've got a 390K or thereabouts in my collection of resistors, I'm going to put a 390K across that. While I'm here, I might as well just get that reading. There's clipping there. We're going into cutoff and saturation there. And that's around about 17.1 volts. 17.1 squared divided by 8 ohms. Hopefully we'll see somewhere between 35 and 40. Perfect. What's that? 36, call it 37 watts. That's about spot on. So we'll just get that little bias adjustment done. Out of curiosity, let's see what our bias now is. Good, gotta love it. 38.5. So we're like half a volt away from that 39 volt figure there. So you've got to give it credit to these designers. They were spot on all the time. Seems like regardless of the valve, if you just follow their specs, you'll be pretty much right. I don't know why I go to all this bother half the time, but that's what you get for being a pain in the ass perfectionist. Right, do you remember your formula for calculating parallel resistances? I'll give you a reminder. It's R1 times R2 over R1 plus R2. In this case we had 56 times 390 divided by 56 plus 390. And 21,840 divided by 446, which is 48.96, which is pretty near enough to damn it to 50. And the original design value was 56. So as you can see, it was just a small adjustment just to get rid of a little bit of that notching from the crossover distortion. And you might be able to see here what I've done is I've just piggybacked that 390 there on top of the 56K. So next time if it needs to get adjusted, or may even need to be just removed with the next set of tubes, it's just an easy clip off and we're back to that standard resistance. So that's done. All right, so let's just try the other controls, the other channel, and see how we go from there. Wow. He was only 21 years old when he made this landmark album, the pinnacle of Les Paul through Marshall tone. What can I say? It sounds way better than I was expecting it to. It's a hybrid amp, solid state preamp, valve power stage, and yet there we were in Eric Clapton Blues Breakers territory. amazing. I'm going to have to change my view on hybrid amps. But I got to say, a large part of it is this beautiful guitar. And that's actually an interesting story, because I got these pickups from Rod McQueen of Sliders Pickups. Great. And said, Rod, can you make me a set of pickups to make me sound like Eric Clapton did in the Blues Breakers era? And he looked at me and he goes, nah, I can make you a set of pickups that will sound similar to what Eric used in his 59 Sunburst, but I can't make you sound like Eric Clapton. Smart ass. I'll see you at the next repair.